So remember when we did cylindrical coordinates, what does dv become? RdR d theta, right? That's dA really. So in cylindrical it would be r dr d theta dz, right? Or whatever order. So in the book I think they officially say it's r yes, r dz dr d theta. Sounds like a sounds like a character in Star Wars that was abandoned. But RDR, screw it. Get somebody else up there. Screw it. All right. So to help figure this out, I'm not going to try to draw this. I want to put this up here. There we go. So I call this the spherical hammer. It always looked to me like somebody just wanted a little bug right here. Smash. Could just be me. So remember how when we went to cylindrical coordinates, when we actually went to polar and we were talking about r d theta by itself, we were talking about there was a polar rectangle. So it was this rectangle that was allowed to be curvy. At least in the crude, when we went to infinitesimally small, then it becomes straight lines everywhere, so it's all good. So I extend that idea to be this kind of spherical rectangle. What do they call it? Spherical wedge is what they call it.
Wedge.
But it's still, yes, all the Star Wars stuff. It's still, I'm going to consider, if I let that thing shrink down to be infinitesimally small, all the curves in it will not be curves anymore. They will be linear in that limit. So really what I want to figure out is what's the volume of that box that I've got sitting up there. So they've got everything kind of spelled out for me. Now can we figure out why this makes sense? Arc length in general is what? In 2D, what's arc length? So if I want to know the arc length here, what two things do I need to know to figure it out? R and yeah, let's call it d theta. Just to be like that. So this would be r d theta, right? This arc length. This arc length basically that would be the change in arc length, right? That'd be the ds. How you guys doing? So does it make sense then? That's acting like r in 3 dimensions, and that is my change in angle there. So that's going to be that arc length there will be rho d phi, right? And of course this is just the change in the 3-dimensional radius, the rho, the radius going out, the spherical radius. So this side is just going to be d rho. This here, you guys see how this goes up there, that other side? So I've got the length, I've got the height, and now I just need the width. I just need this piece here. And that's the piece that gets really interesting. This is, of course, rho sine phi. That's that extra piece that we slammed it into the xy plane earlier. And then I just got to multiply by, so this is like the r, this is the r from polar. And then I multiply by the angle, that's our normal arc length. So that makes sense too. Rho sine phi, delta theta. So then I end up with, oh, you missed all that, that's too bad. You end up with dv equals rho sine phi d theta times d rho times rho d phi. Dude, so really, let's put this together better. This becomes rho squared sine phi. I can't remember which order they like to put it in. D rho, d theta, d phi. Oh, I got close. They like d rho, d theta, d phi. Say again?
Where does this problem in the book? Or it's in
That figure is on page 1087. You gotta like being, or I don't know, you don't have to like it, but being on page 1087, the book is different. And at the bottom of the page, they show you the full way that it looks in spherical coordinates for an interval. Schlabang. So let me see.
You're not going to integrate that?
There's nothing to integrate. This was just figuring out what dV is.
Yeah, so you don't want B?
You got to have limits, right?
Yeah, I know.
So you could, if you wanted to know just the volume over some certain thing, then you certainly can do this, right? With a 1 in here, right? Okay, so let me do this right now. I got this little thing here. I think we can do this. This is sort of a review of cylindrical and spherical. So if you wanted to, you could attack the spherical ones right now, since we just finished talking about it, and then try to attack the cylindrical coordinates after that, a little review.